Hi, everyone. My name is José Antonio Bayona, and this is my case study for the University of Bristol's Open Research Prize 2022. I would like to start this presentation by introducing my research group to you, and that is the Collaboratory for the Study of Earthquake Predictability, CISEP. CISEP is a global and open community whose mission is to support earthquake predictability research through fully prospective testing of seismicity forecast. And with this term, prospective testing, I mean the evaluation of seismicity models against future earthquakes. For more than 10 years, CISEP has conducted multiple earthquake forecasting experiments at regional and global scales, in which the Earth serves as a natural laboratory and earthquakes are the object of study. So I find this really, really fascinating. Recently, my research fellows and I conducted one of these earthquake forecasting experiments in California using 10 years of prospective data. In particular, we evaluated the ability of 22 seismicity models to forecast earthquakes with magnitude larger than 5 in California from 2011 to 2020. 6 of these models, which I refer to as parent models, were based on a wide variety of geophysical data sets, including smooth seismicity, tectonic data, and crustal deformation rates. The rest of these models, which I refer to as hybrid models, literally combine the feature of their parent models into single seismicity models. And in this manner, they have the potential to gain predictive skill. In a retrospective evaluation, some of these hybrids showed great forecasting capacities. However, only prospective evaluations can be considered rigorous enough to describe the stability of these test results. And this is why we conducted this investigation. Contrary to retrospective outcomes, our prospective evaluation showed that a model that smooths the locations of small earthquakes was the most informative seismicity model during the evaluation target period. And from a scientific point of view, this is really, really interesting because this denotes that small magnitude seismicity can be useful, is useful for forecasting the occurrence of larger events in California. So these scientific results can be fully reproduced by anyone because I am providing the data, the code, and the documentation to do so. Traditionally, or previously, these input data and software artifacts were stored in CISEP servers with no community access in order to ensure the integrity of the experiments. And this was, of course, very beneficial, but on the other hand, it also made it very difficult to share the results with the scientific community. And that is why we are proposing this change in research culture by providing the data and the software required to conduct this experiment in your own computer. So this open research practice involves this data repository, which is freely available in Zenodo, and which contains the evaluation earthquake catalog as well as the earthquake forecasts. As of March 2022, 547 downloads have been made, so that is not too bad. This data repository is linked to a software reproducibility package, which is also freely available on GitHub. And this reproducibility package performs the computations to generate the figures that we are presenting in our publication. So the user can very easily reproduce these results by following the description listed in this documentation file and running these 3 lines of code. So when the user does it, the algorithm is going to create these folders. And if she or he clicks on this one here, he or she is going to find this bunch of figures which are presented in the paper. So I'm going to briefly show one example. This is the figure showing the parent forecast models that underwent a prospective evaluation, and that is exactly the figure we are presenting in our paper. So this paper, of course, was published under a open access license in order to embrace the open research spirit. So with all this in mind, I hope I was able to convince you that by 1, storing the data in a publicly available data repository in Zenodo, 2, providing the code on GitHub, and 3, publishing our scientific results in an open access publication, we at CSEP are advancing earthquake predictability research with open research practices. Thank you very much for your attention, and I will be very happy to take questions you may have.